Hi there. Today we're diving into NEC 110.3a, a key rule in the National Electrical Code that's all about making sure the electrical equipment we use is safe and fit for the job. Don't worry, we'll break it down into simple terms so you can understand exactly what this rule covers and why it's so important. Alright, let's start with the basics. NEC 110.3a talks about how all electrical equipment, things like wires, outlets, circuit breakers, and other electrical devices, must be carefully examined before they are used in any electrical installation. The goal here is to ensure that the equipment is safe, reliable, and appropriate for its intended use. In simpler terms, this rule says that we need to check if the equipment is in good condition and works properly before using it. This way, we can prevent accidents like electrical fire shocks or equipment failures. So why was the NEC 110.3a created? Well, it's in place to make sure that only safe, reliable, and suitable equipment is being used in electrical systems. Think of it as a checklist that electricians follow to ensure electrical components are fit for the job and won't pose any risks. If electrical equipment isn't properly examined, it could fail to work correctly or even cause a dangerous situation. This rule is all about keeping people safe, whether they are electricians or end users of the electrical systems. Now, let's break down the NEC 110.3a into what it covers. Here are key factors that need to be examined before using electrical equipment in an installation. First off, the equipment has to be suitable for its intended use. For example, if you have an electrical part designed for outdoor use, you shouldn't use it indoors. A device meant for high voltage shouldn't be used in low voltage settings. As an example, you shouldn't use an outdoor light fixture designed to handle rain and snow inside your home, right? That's not safe or suitable for indoor conditions. Next, the equipment needs to be strong enough to handle the physical demands it might face. For example, a circuit breaker box needs to be sturdy enough to protect the wires inside from damage. Another example, imagine a plastic electrical box. It should be tough enough to protect the wires from physical impact and not crack under pressure. Next, there also needs to be enough room in the equipment to safely bend wires and make proper connections without causing strain or increasing the risk of overheating. For example, when installing an electrical outlet, the box needs to have enough space so that the wires can bend and connect without being cramped. If the wires are squeezed, they could overheat, which is dangerous. Next, the equipment must have proper insulation to prevent electrical shocks or short circuits. Insulation ensures electrical current stays where it's supposed to. For example, wires are coated with insulating layer, like plastic, so people don't touch the metal wire inside and risk getting shocked. Next, the equipment must also be able to handle heat, both under normal use and during abnormal conditions like a power surge or a short circuit. For example, a circuit breaker is designed to get warm under normal use, but it's also built to withstand heat from things like power surges, which catch fire without catching fire. Another important thing is to check whether the equipment can handle arcing. That's when sparks are created during connection or disconnection of electrical circuits. These sparks can cause fires if not properly controlled. Example, a light switch should be designed to break the electrical current without sparking when you turn it on or off. If the switch isn't designed properly, it could cause a dangerous spark. Next, the equipment also needs to be classified for its specific use, whether it's for high or low voltage, what size it is, how much current it can handle, etc. It should match the requirements for the job. For example, you wouldn't use a high voltage transformer meant for industrial factory in a home. It's made to handle much higher current and voltage than what a regular outlet in a house can provide. And finally, the equipment should contribute to overall safety, whether that's protecting against shocks, fires, or other hazards. As an example, a GFCI outlet is designed to protect people from electric shocks, especially in wet areas like kitchens and bathrooms. Let's put all this into perspective with an example. Imagine you're an electrician installing a new circuit breaker in a commercial building. Before you install it, you'll check for the following. First, suitability. You ensure the breaker is right for the type of wiring and voltage of the building. 2. Strength and durability. You make sure the breaker can withstand the physical environment and protect the equipment inside the electrical panel. 3. Wire, bending, and space. You'll check that the breaker box has enough room to allow for proper connections without overloading the wires. 4. Electrical insulation. You'll make sure that the breaker parts are insulated to prevent electrical shorts or shocks. 5. Heating and arcing. You'll confirm that the breaker can handle heat from normal use and prevent arcing. And 6. Classification. You'll ensure that the breaker rating matches the building's power needs. Once you have checked all of these things, you can confidently install the breaker, knowing that it's safe, reliable, and up to code. NEC 110.3a is super important because it helps ensure that electrical equipment is safe to use and won't cause hazards like electrical shocks, fires, or equipment failures. This rule sets quality control standards that must be followed to prevent both electricians and everyday people from electrical dangers. So let's wrap up what we have learned. NEC 110.3a outlines what needs to be examined to ensure electrical equipment is safe and is fit for use. The equipment must be strong, well insulated, and able to handle heat and electrical surges. Following these rules helps prevent dangerous situations like fires, shocks, and equipment breakdowns. So here are the key takeaways for 110.3a. Before using any electrical equipment, it must be thoroughly examined for safety and functionality. The equipment needs to be strong, insulated, and able to handle heat and electrical surges. Ensuring the right equipment is used helps prevent accidents and ensures that your electrical system works properly. Thanks for joining me today. Hopefully, this clears up what NEC 110.3a is all about, and why it is so important for keeping electrical systems safe and reliable.